welcome to Next Gen Manufacturing Nexus. Today we're going to talk about a piece of technology you've probably never really thought about, but it is absolutely everywhere, playing a critical role in saving lives and, believe it or not, in exploring space. Let's get right into it. Okay, first question for you. How do you kill a superbug? Just imagine you're up against this microscopic enemy. A pathogen is so tough it can survive almost anything. And it's sitting right there, on the surgical tools that are supposed to save someone's life. How do you make absolutely certain it's gone? All right, now let's do a complete 180. You're an engineer, and your job is to build a part for a spaceship. It needs to be unbelievably strong, but at the same time, crazy lightweight, or it'll never get off the ground. How in the world do you make a material like that? So you have these two massive, completely different problems, right? A medical nightmare and an engineering puzzle. Well, what if I told you the answer to both is the exact same machine? It's called an autoclave. And it's this high-pressure hero working behind the scenes as both a master destroyer and a master creator. So first, let's really dig into the problems. Because you gotta understand the scale of these challenges to really appreciate how elegant the solution is. We've got invisible killers on one side, and on the other, the huge hurdles of next-gen manufacturing.
So yeah, in medicine, you are in a constant war against infection. Every single tool has to be perfectly, completely sterile. No exceptions. Then, in advanced manufacturing, especially aerospace, they're trying to build things that defy the old limits of material science. Two totally different worlds, but they both rely on this one incredible machine.
So how does it actually work? What's the secret sauce? Well, it isn't just about getting things hot. It's about a really clever, really powerful application of basic physics. It all comes down to the power of pressurized steam. The concept is actually beautifully simple. You take regular steam, lock it inside a super strong, sealed chamber, and then you just crank up the pressure. When you do that, the temperature of the steam skyrockets, way beyond its normal boiling point. And that superheated steam, well, that's your weapon. It's what kills the germs, and it's the force that forges these brand new materials. And this is where the magic really happens. Look, at normal atmospheric pressure, water boils at 100 degrees Celsius. We all learned that in school. But inside an autoclave, if you add just 15 psi of pressure, that's about what you'd put in a bicycle tire. That steam suddenly jumps to 121 degrees. Double the pressure to 30 psi, and boom, you're at 134 degrees. This isn't just hot water anymore. It's an incredibly powerful, penetrating force that destroys microbes that would just laugh at simple boiling. You know, it's not just brute force either. There are a couple of really clever strategies it uses. The simpler method is called a gravity cycle. Hot steam gets pumped in the top, and because it's lighter than air, it literally pushes the colder, heavier air down and out through a drain. But the more advanced method is the vacuum cycle. This thing actually sucks all the air out first. It creates a total vacuum, so when the steam rushes in, there's absolutely nothing in its way. It instantly penetrates every single tiny nook and cranny. Super fast, super effective. Okay, but here's a really crucial point. When the stakes are this high, we're talking lives or billion-dollar equipment, you can't just cross your fingers and hope it worked. You have to prove it, scientifically, and that whole process is called validation. I mean, think about it. In a hospital or a biotech lab, you need ironclad documented proof that every single sterilization cycle was a 100% success. There is zero room for error. Lives, research, it all depends on being absolutely certain. So how do you prove it? Well, with a strict three-phase check. It's called IQ, OQ, and PQ. First up is IQ, installation qualification. That's basically just checking, is it hooked up right? Is the electricity, the water, the steam all correct? Then comes OQ, operational qualification. They run the machine empty to prove it can hit the target temperature and pressure. And finally, the ultimate test, PQ, performance qualification. They load it up with real items and confirm a perfect kill under actual working conditions. So, the autoclave seems pretty much invincible, right? A perfect destroyer of microscopic threats. But what if I told you there's something out there that it can't kill? For all its incredible power, its ability to just obliterate bacteria and viruses with superheated steam, there is one bizarre, almost alien contaminant that simply defies it. Everybody, meet the prion. Now get this, it's not a bacterium, it's not a virus, it isn't even technically alive. A prion is just a protein that is folded into the wrong shape. But here's the creepy part. It's like a zombie protein. It bumps into other healthy proteins and forces them to misfold too, creating this devastating chain reaction. As a user on Reddit explained it perfectly, their danger lies in their stability. Prions are folded into a structure that is so incredibly robust that it's just ridiculously difficult to break them down or denature them with something like heat. And that right there is the autoclave's one big weakness. See, it works by using heat to shred the DNA or RNA of living things. But prions don't have DNA. They're just these incredibly stable proteins. So a standard autoclave cycle, they just shrug it off. So what do you do if you even suspect a surgical tool has been contaminated with prions? The answer is stark. You can't risk it. The only universally accepted way to destroy prions is to incinerate the tool. You have to burn it. End of story. All right, so we've seen the autoclave as a destroyer, a guardian of our health. But that is only half the story. Now let's switch gears and look at its other identity, the autoclaves as a creator, forging the very materials of our future. It's a really fascinating duality, isn't it? The exact same force, that intense combination of heat and pressure that's used to wipe out microscopic life, is also the perfect environment for creating some of the most advanced materials on the planet. In manufacturing, an industrial autoclave is basically a giant, high-pressure oven. You take layers of a composite material like carbon fiber, put them inside, and that intense heat and pressure cures the resin, bonding all the fibers together into one single, incredibly strong and lightweight part. It creates a perfect, flawless component that's way better than most metals. And where do you find these parts? You're looking at the nose cones on rockets, the wings of modern jets, the main chassis of a Formula One car, and the bodies of high-performance drones. Basically, anytime you need the absolute maximum strength for the minimum possible weight, you can bet that part was born inside an autoclave. So the autoclave is a true unsung hero, a machine of incredible contrasts, a protector against disease and a builder of our most advanced technology. All of its power came from mastering the simple physics of pressurized steam. And it really makes you wonder, doesn't it? What fundamental force will the next generation of innovators harness to build the world of tomorrow?